All right, so we're going to find the inverse for this function. Okay, so let's write out the steps again. So the steps are, 1, we're going to replace f of x with y. Step 2, we're going to solve for x equals some stuff. Three, we're going to swap the x's and y's. In other words, wherever there's an x, you put a y. Wherever there's a y, you put an x. Lastly, you're going to take y and replace it with the inverse function notation, which is f raised to the -1. That's not what it means, but that is really f inverse. So let's keep that in mind. This is how you say f inverse. Now, the reason I'm writing this down, and I'd like for you to write this down in your notes, is so that every problem you look at, like maybe you do your homework, there's going to be a problem like this. I want you to have the recipe in that problem, because some of you guys don't go back and look at all the notes. Also, every time you write it down, it goes in your brain. Remember that 27 times we want to get it in there? All right, so let's do that. So I have f of x is equal to 3x minus 1. Step 1, replace f of x with y. Done. Check that off the list. Okay. Next step, solve for x. So I'm going to add 1 to both sides. And over here, I'm just going to say y plus 1, because they're not like terms, is equal to, now 1 minus 1 is 0. 0 plus 3x is just 3x. 3x is 3 times x, so to move the 3 away, we're just going to divide by 3. Whatever I do on one side, I have to do to the other. 3 divided by 3 is 1. 1 times x is just x. Okay, we've solved for x. Check that off the list. Next step, 3. Wherever there's an x, we put a y. Wherever there's a y, we put an x. So I've got x plus 1 over 3 equals y. Check that off the list. Step 4. Now I'm going to write it, I'm going to switch the order because I just want to. So I'm going to say f inverse of x is equal to this stuff right here. This right here. X plus 1 divided by 3. Now, who remembers what I said yesterday in our example? How can I double check to make sure the algebra that I did was right? Does anybody remember? What did I say you could do? Easy peasy. Well, there's a couple of things. One, here I'm multiplying by 3. On the inverse function, I'm dividing by 3. Here I'm subtracting 1. On the inverse function, I'm adding 1. Now, as the equations get a little more complicated, it's kind of hard to track that. So that's step 1. You're doing the inverse operations. Okay. The other way is graphically. Graphically is really easy. If you don't have a fancy, I left the fancy calculators out. If you don't have one, grab one. But I want you guys to practice this too, and I'm going to do the big screen so you guys can see it. Okay. So, oops, you guys are seeing my little cheat sheet here. Not that I need a, I like to look at it and make sure that I didn't make a mistake. We don't want that. Hide that. We want this one, large display. All right, cool. So when I get to y equals, I'm going to plug in the function that they gave us first, which was 3x minus 1. okay? And then I'm going to plug in the inverse function. Now, when you do the inverse function, you got to put the numerator in parentheses. So that would be x plus 1, and then divided by the denominator. Now, if you have more than one term in the denominator, that also has to go in parentheses. But since we only have 3, we could just do it like this. And then I'm going to need the dotted line. Now, remember, that equation is y equals x. And also, you can make a dotted line if you want to. On the older calculators, it's a little more challenging to get to it, but it's an option. You just got to go over here, and then you got to keep hitting. On the older calculators, you just keep hitting enter until you get something, until you get an image that looks like this. So I'm going to hit OK. All right. And then I'm going to do zoom standard just to see. And so what you see here is that our first function, right, 3x minus 1 is this blue graph. Our inverse function is the red graph. And then the diagonal line is the black. It's supposed to be dotted, but it's kind of big. But notice that the blue is the mirror image of the red. Now, the calculator is slightly distorted. In other words, the x-axis is a little bit longer than the y-axis. But you would know right away if you had something, like if I made an algebra error, it would not look anywhere close to symmetrical. Okay? Does that make sense? Now, another way to check this is you can hit second. Well, let me take a screenshot of this. We'll sketch that in our notes in a second. Okay, but you could go to second table and I don't know why I was counting by 30. And you'll see that the x's and y's are flip-flopped. So let me go to the smaller numbers so it's a little easier. So when this one says, let's do this one. So on the first function, when x is 2, y is 5. So now if I scroll down to 5 for x, notice that this one, y is 2. So they flip-flop, okay? They flip-flop. Notice that when x is 3, y is 8, but if I scroll down to 8, this y is 3. So the x and y's kind of flip-flop, okay? That one's a little harder to see. Anyways, let's plug this in here. And let's label that. So just kind of sketch this in real quick. So this is f of x equals 3x minus 1. This is f inverse of x, which is equal to x plus 1 all over 3. And then lastly, don't forget that this diagonal line is just y equals x. That's how we're going to double check these every time. Are there any questions on that?